So today we're going to be solving simultaneous equations using the elimination method, right? And on the right, I've written a few steps just to guide us along the way. Okay, so we're given these equations: 2x plus y is equal to 5. That's the first equation. And x plus 3y is equal to 5. That's the second equation, right? And before we go into this, I just want, for those that don't know, the coefficients of a variable, for example, the coefficient of x over here is 2, right? And the coefficient of x over here is 1. The coefficient of y over here is 1, and the coefficient of y over here is 3. So it's basically the number before the variable. All right. So our first step says make coefficients of x's or y's the same, right? So it's either we want these coefficients to be the same, all right, or we want these coefficients to be the same. In this case, I feel that making the coefficients of the x's will be easier, right? So the coefficient of this x is 2. I want to essentially make this 2 also, right? And to do that, I would have to multiply the whole equation by 2, right? So let's do that. This is the first equation. 2x plus y is equal to 5, all right? And this is the second equation, because I'm essentially saying x times 2, which gives me 2x, plus 3y times 2, which gives me 6y, plus is equal to 5 times 2, which is equal to 10. Okay, and this is our second equation. So we've done our first step. The second step is to either add or subtract equations to remain with one variable. So essentially what we're doing is we're either going to add these two equations or subtract them to get rid of either the x's or the y's. All right, so for this, I have a little trick that you can use. And to do that, we would look at these signs here, right? If these signs are both the same, we essentially want to subtract the equations. And if they're different, for example, if they're plus and minus, we want to add the equations. All right. So in this case, we have plus and plus. So we want to subtract the two equations, right? So I'll choose to subtract the top equation, the first equation, from the second equation. So I'm saying the second equation minus the first equation. And this is essentially saying 2x minus 2x, which will give me 0, right? 6y minus y, which will give me 5y, plus 5y is equal to 10 minus 5, which is equal to 5. All right, so this is basically saying 5y is equal to 5. We can divide both sides by 5, and you're left with y is equal to 1. All right, now we can substitute this y back into either this formula, this equation, sorry, or the second equation, right? I'll just pick the first equation. So 2x plus y is equal to 5. I substitute the 1 in, and I get 2x plus 1 is equal to 5, right? 2x is equal to 4. Divide both sides by 2, and you get x is equal to 2. All right, so this would be us solving these equations simultaneously. All right, now let's move on to our second example. All right, so in this case, we're given the equations 3x plus 2y is equal to 7. That's the first equation. And 2x minus 3y is equal to negative 4. That's the second equation. And the procedure is pretty much the same as the first example, except in this case, we have to find a common factor. I'll show you why. All right, so we can choose to make either the coefficients of the x's the same or the coefficients of the y's the same. All right, so randomly, I'm just gonna, because I feel like the difficulty level will be the same for both, I'll just pick y. All right, so we're gonna make the coefficients of y's the same. All right, and to do that, I would have to find a common factor of 2 and 3, which would be 6. All right, so to make 2 equals 6, I would have to multiply by 3. And to make 3 equals 6, I would have to multiply by 2. Alright, and essentially this is multiplying the whole equation. Alright, so this would come down to 3x times 3, and I'll get 9x, plus 2y times 3, and I would get 6y is equal to 7 times 3, and that is 21. Right? And 2x times 2, that'll give me 4x, minus 3x times 2 will give me minus 6y, and minus 4 times 2, and that is equal to minus 8. Alright, so this is my first equation, and this is my second equation. Right? So in this case, you can see that the signs are different. Right? It's plus and a minus. So in this case, we would add the two equations. But what we're essentially doing when I say add and subtract in the previous example is getting rid of this variable. Right? We're getting rid of the y's in this case. And to get rid of the y's, if I say negative 6y plus 6y, I'll get 0. Right? That is why we are adding. We're just getting rid of the variable. Right? So let's say 4x plus 9x, I would get 13x. 6y minus 6y, I would get 0y. Right? 21 plus negative 8 would be 21 minus 8, and that would give me 13. Alright, so 13x is equal to 13. Divide both sides by 13, and I get x is equal to 1. Alright, now we can plug this x back into either this equation or this equation. In this case, I'll pick the second equation. Right? 4x minus 6y is equal to negative 8. Right? Plug the 1 in for x. Plug 1 in for x. Minus 6y is equal to negative 8. I'll get 4 minus 6y is equal to negative 8. Right? So 6y is equal to 4 plus 8, which is 12. Divide both sides by 6, and you get y is equal to 2. And these are our solutions to these equations when you solve them simultaneously.